What's up, math scholars? It's Mrs. Harp here, joining you for a 1.3 Day 2 video. We have already learned how to factor, but now we're going to learn how to solve. Who's excited? Woo! I have a secret. I'm in an empty classroom. It's a little more exciting with a live audience, but you get what you pay for here. Just kidding. All right, so let's start with the zero product property. The zero product property states, if A times B equals 0, then either A equals 0 or B equals 0. I'll give you a second to jot that down. And it makes sense. If you have two numbers that have a product of 0, one of those two numbers has to be 0. Now, you might be wondering how we're going to utilize that with the factoring that we've been doing. So the factoring that we've been writing out two binomials, maybe like x minus 3 and maybe like x plus 5. Well, today you'll have an equal sign involved, and you'll have an equal 0 over here. And if you don't have it equaling 0, you'll have to get it equal to 0. And that's going to allow you to finish the problem out. Basically, what we have here are two things being multiplied together to get 0. So either this thing had to have been 0, or this thing had to have been 0. I shouldn't call them things, I should call them binomials. So either x minus 3 is 0 or x plus 5 is 0. And then we solve to discover that either x had to have been 3 or x had to have been negative 5. If x was not 3 or x was not negative 5, one of those two, it could not have had a product of 0. Okay, so you end up getting two answers, and you put the word or in between them. Okay. All right, so here's going to be our strategy with the equations we'll be solving today. To solve these equations, we're going to want to get everything on one side of the equation and get our equation set equal to 0, and then factor. Once we've factored, since we're set equal to 0, we can finish by utilizing the zero product property. Okay? If you do feel like you want to write those steps down, pause the video at any time, write those steps down. Otherwise, why don't you go ahead and write down the problem x squared plus x minus 6 equals 0. So it is that old-fashioned technique of factoring where we're looking for numbers that multiply to negative 6 that would add up to a positive 1, because there's an invisible positive 1 right there. Let's do some brainstorming. Did you figure it out? We want to go with a positive 3 and a negative 2. Now, since we're set equal to 0, this is where the zero product property comes in. Since x plus 3 times x minus 2 equals 0, one of these two has to be true. Either x plus 3 equals 0 or x minus 2 equals 0. So you can solve that. Most people do the step in their head. X would be negative 3, or x would be 2. Now, we haven't really talked, but you can always go back and check your work. Going back to check your work is what a true scholar would do here. So what this is basically saying, if you go back to the top, this original equation, and check your work, you can check that negative 3 squared plus negative 3 minus 6 is 0. Notice I put the parentheses around there. It's important to use parentheses if you're using a calculator, but you can just use your brain power. It'd be 9 plus a negative 3 minus 6. So that would end up being 0. So that does check out. But you can also check your other answer of 2. There's two answers. Is 2 squared plus 2 minus 6 going to be 0? 4 plus 2 minus 6 sure is going to be 0. So both of those answers check out. Now, you won't see me checking my work all the time, but it is a good idea if you're taking a quiz to be checking your work. All right, so any questions on that one? Right. I know I have an empty classroom, but I had a visitor peek his head at the door. All right, so remember, before we use our strategy of factoring to solve and finish using the zero product property, you have to get everything on one side of your equation. So this negative 10 is pesky right now. We don't want it there. We don't want to attempt factoring until that negative 10 has been moved. And to move it, we'll add 10 and combine our like terms. So x squared minus 7x plus 6 equals 0. Let's go ahead and finish that off with the old-fashioned factor technique. What numbers add up to 6? Sorry, multiply to a positive 6, but add up to a negative 7? Beware of the double negative. It's a negative 6 and a negative 1. So finishing off with the zero product property, either x minus 6 is 0 or x minus 1 is 0. And if you can jump straight to the answer solving these in your head, you could actually go from this step flat out to the answer. I'd be fine with that. That's what all the scholars are doing these days. Your final answers are 6 or 1. And feel free to check your work if you want. All right, here's our next one if you want to jot it down. Now we do want to get everything onto one side, and we do want to get set equal to 0, but I don't like dealing with a negative x squared, so I'd probably keep this guy where he's living at on the right-hand side. I would subtract my 9x over to the right-hand side, and I would add my 8 over to the right-hand side, so everybody could be living on the right-hand side together, and that way I can be working with a positive x squared when I go to factor. So hopefully that made sense to you. Time to factor, everybody. What numbers multiply to positive 8 and add up to negative 9? Beware of the double negative. That's right. It's a negative 8 and a negative 1, making our final solutions 8 or 1. Wow, look at this one. Crazy, crazy, crazy. You might wonder how in the world are we going to factor something that already kind of sort of looks factored. You're seeing those sets of parentheses? Well, I've got some news for you. We're going to distribute. Then we're going to get everybody on one side, so we're set equal to 0. Then we'll factor, then we'll solve. Did you follow my game plan? It's going to be a wild ride, so buckle in. Let's distribute this x. It'll be x squared plus 9x. All right, on the right-hand side, we'll do the same thing and distribute this too. So 8x plus 2. Now our next game plan is, of course, getting everything set equal to 0. I love this positive x squared on my left, so I'm going to get all my other terms brought over to that left side. Will be gone, so my 0 will be on my right side. And then we're just finishing off with the old-fashioned factoring technique. What numbers multiply to negative 2? That would add up to 1, a positive 2, and a negative 1. Hopefully you were thinking of that combination. That makes our solutions a negative 2 and a positive 1. Technically, got the word or in there. All right, this is our last problem before we get into 2 word problems, so this will be fun. Let's get everything set equal to one side. We're going to subtract over the 25y to join the 5y. And then we're going to see how well you guys remember Algebra 1. Do you remember Algebra 1? Those were fun days, weren't they? There is a technique called the common monomial technique where you pull out what both of these terms have in common, the biggest number and the most variables. We'll get into this maybe a little more in the future, but for today it's very easy. Both of my terms have a 5y in common that I will be pulling out front. It's like backwards distributing. It's called a greatest common monomial. What I would have left inside is a y and a negative 5. So what I see here would redistribute to 5y squared minus 25y. Now here is how I would utilize my zero product property. This monomial times this binomial is 0. Therefore, either my 5y has to be 0 or my y minus 5 has to be 0. If I would solve 5y equals 0, I would divide both sides by 5 and get 0. And then, of course, over here, I would add a 5 to the other side and get 5. So there is my answer, y equals 0 or y equals 5. Feel free to check your work. All right, our first of 2 word problems. Let's read this together. Let's draw a picture if that will help us, which it certainly will. We're talking dimensions of a stage. The dimensions of the old stage at the concert hall were 30 feet wide and 15 feet deep. 30 feet wide by 15 feet deep. The new stage has a total area of 1,000 square feet. The dimensions of the new stage were created by adding the same distance x to the width and depth of the old stage dimensions. So we're basically going to have our new stage will be 30 plus x as the width and 15 plus x as the depth, and the area will be 1,000. Now it'll be width times depth, length times width to get that 1,000. So let me scroll a little bit, give myself some room. So it'll be 30 plus x times 15 plus x to give us that 1,000. Let's go ahead and distribute. 30 times 15, might need a calculator. That's a bigger number, 450. Maybe you can do it in your head if you're a scholar. 30 times x, 30x. 15 times x, 15x. And then finally x squared. So there's my FOIL. I'm going to need everything set on one side so I can be equal to 0. So I can finish with some factoring. Let's go ahead and combine these like terms. That would be 45x. Let me put my x squared out front, and then I'm going to subtract 1,000 over to join this 450. All right, it's a little bit more challenging when you are factoring using larger numbers, but we still just need to multiply to the negative 550 and add up to the 45. So give it a second, think about it. I'll give you a second to try some numbers out in your calculator, see if you can figure out our magical combination. It's going to be 55 and negative 10. So that makes our two answers negative 55 or 10. Now, this is a real life problem, so you really got to think. If you're adding a dimension on, you can't add a negative 55 on. You can only add a 10 feet on. So that's really the only answer that makes sense. This is an answer that just doesn't make sense in a real life situation. Something that, for example, something dealing with dimensions. Okay? Full screen, we can see all of the problem. All right. And finally, our problem that will separate the scholars from the non-scholars. The picture frame problem. Whew. Everybody take a deep breath. Repeat after me. I am a scholar. We can figure this out together. You're making a square frame of uniform width for a square picture that has side lengths of 2. The total area of the frame is 5 square feet. What is the length of the sides of the frame? All right, so when they say the total area of the frame is 5 square feet, it's this colored in gray stuff. So what I did is I kind of split my picture frame into this rectangle here. We'll call these my pink rectangles. This rectangle here. And then these green rectangles here, the long skinny greens that are on the sides. So let's kind of start off with the pinks. The pinks, right here, I'll get my marker again, will for sure be 2 feet on one side. But then on the other side, this dimension right here, the width, I guess you can call it, would be x minus 2. Because I'm kind of thinking about shoving these together. Does it make sense? X minus 2 would give you what's left here with what's left up top. Oop, didn't mean to do that. But hopefully you can see that. So if I would take the pinks and put them together, one side would be 2, the other side would be x minus 2. I would almost use smartboard magic to put those pink squares beside each other. Almost. But can you picture it? One side would be 2, the other side would be x minus 2. Hope you can see that. All right, so now let's talk green. The greens, if I put them beside each other, it's going to be a really similar concept. One dimension would be x, the other dimension would be x minus 2 again. And then total, they told us our area was a 5. All right, I'm pretty sure you know how to finish from here. FOIL everything out, get everything set equal to 0, factor, and solve. Here we go. That would be a 2x minus 4. That would be an x squared minus 2x. We can combine our like terms, which I'm underlining now. Notice our like terms will go away. We'll just have an x squared minus 4 on this left side. Our 5 is hanging out on the right side. So I'll bring my 5 over. I'll have x squared minus 9 equals 0. And that's a difference of perfect squares. Positive 3 and negative 3 are the numbers that add to 0 and multiply to negative 9. So our answers are negative 3 and 3. And same deal, since this is a word problem, and we're talking about what's the length of the side of the frame, what is x, it has to be a positive number. So 3 feet is our final answer on that problem. Well, not the easiest problem we've seen this year. In fact, maybe the hardest problem we've seen all year, but thanks for sticking with me and being a scholar today. Ta-ta.